Hello everyone, and welcome to Petrosys webinar series. My name is Eric Wright. I'm a geotechnical support analyst here at Petrosys. In this webinar on directional mapping, I'll be briefly going over some of the options that are available to you to map directional features in Petrosys. To provide a more streamlined presentation, everyone will be muted during the webinar. If you have any questions, you are welcome to type them in the chat log as we progress. This meeting will be recorded and uploaded to our website later. So getting started, the purpose of this webinar is to demonstrate the varied ways we can use Petrosys PRO to map certain 3D geological features on a 2D surface. Before we move on to the demonstration, I'll briefly introduce what we're going to cover. So why would you use Petrosys PRO to map directional features? Perhaps you want to display simple strike and dip, model migration pathways, or look for traps or stress patterns. We have several ways you can accomplish that goal in Petrosys, and we'll be talking about 3 of them today in this webinar. The 3 methods we'll be talking about today are dip and azimuth grids, thematic mapping of point data, and orthocontours. So let's take a look at some of the ways we can model direction in Petrosys PRO before moving on to the demo. The first method I'm going to show you today is our dip and azimuth grids. A dip and azimuth grid will populate your grid surface with vectors that represent dip and azimuth. As you may know, a dip is the angle that your surface makes with the horizon, and azimuth is the direction in which your structure is dipping at that point. Another of the ways we can map directional features is by using thematic mapping. Say if you have point data with a directional bias, we can represent that bias by selecting an appropriate symbol shape and changing various aspects such as its orientation, its size, and its color to help us represent certain features. You can see here in my picture, I've used strike and dip symbols, but you can use also ellipses, triangles, various other symbols we have. Okay. We also have orthocontours. These are lines that follow the maximum gradient of your structure, and we can use these to model migration pathways. They do not take into account attributes such as pressure or those changes related to stratigraphy. As the name suggests, they cross your structural contours at 90-degree angles, which you can see here in this little picture. And now we'll move on to the demonstration. Let's go ahead and get our mapping module open in Petrosys. That for you. You can see here that my map is populated with dip arrows. Each dip arrow has been scaled to the amount of dip. The purpose of this display is to make it easy to see the rate at which our structure is changing at a glance. And to display one of these dip and azimuth grids, we first have to go into surface modeling and do a little background work to make these grids. So let's go ahead and get surface modeling open up. Once you have surface modeling open, we can go to Grid, Processes, and Dip and Azimuth. Upon selecting this, a little window will come up prompting us for our input grid on which we'll make our dip and azimuth calculations and our output files. The dip file will store a scalar value. The azimuth file will store the directional component to the dip and azimuth grid. So we'll go ahead and hit OK here, and we'll go ahead and let it run. You can see it's a relatively quick feature to run, even on very large data sets. It doesn't take as long to compute as standard gridding operations might. So now that we have that run, let's go back into mapping. So to display the dip and azimuth grid we just created, we will need to go to Display, Grid, and Dip and Azimuth. This will bring up another window prompt asking us for the files we just created for the dip file and the azimuth file. There's other options we can change here. We can limit the size of our dip and azimuth arrows. We can also scale them with the amount of dip. For now, I'm going to hit OK here. And you can see now my map has been populated with dip and azimuth arrows. In contrast to dip and azimuth, in contrast to showing you dip and azimuth via a Petrosys grid, I'd like to show you how you can do it using GIS data. So I have some GIS data already prepared here. I'm going to turn this on. So you can see here on my map, I have some point data represented by these strike and dip symbols. This data is coming from a spreadsheet, which contains X, Y values and orientation. I'm displaying this data using our thematic mapping function. Thematic mapping is a way to make your data appear different depending on the values contained within that data. So for example, we could control the color, the size, and the orientation of the symbols we use to represent our data, which is what I've done here with these diptychs. It is a powerful tool for visual analysis. And again, if you don't want to use diptychs, we also have a wide variety of other symbols we can use. So for example, an ellipse. If you'd like to use an ellipse, we can do that as well. So let me go ahead and show you how to do that. So to display your GIS data, we're going to go to Display and GIS. You can see here in this little window next to GIS data source that we accept a wide variety of sources: Excel, Esri formats, shapefiles. I have Excel selected as mine is coming from a spreadsheet. Let's go ahead, okay, and you can see all my data has already been filled out. And let's go ahead and get an appropriate symbol for our GIS data. So we're going to go here to Shape. We're going to go to Point Style. And I'm going to go ahead and just get that strike and dip mark earlier. I'm going to change the size. And now to thematically map our data, we're going to go here to this tab on the right-hand side that says Thematic Mapping. We're going to check this box that says Enable Thematic. For this webinar, we'll be mapping the symbol style. And you can see here, there's different variables we can map. We can change, as I said, we can change the orientation, the color, the length, the width. For the spreadsheet that I'm using, I have values set for orientation. And if you would like to preview your shapes, we can go here and click this little box that says Preview. And you can see we can scroll through our preview and we can see how our data is affected. Okay. I'm going to get a OK here. All right, and now you can see all my symbols I've populated on my map. And if we want to play around with it, we can also change the color, the length, the size, what have you. And, one of the last things I want to show you in this webinar is how to make orthocontours. Say if you had a structural high where you wanted to drill a well, say right here, for example, and you wanted to visually represent that area that the area that structural high might be draining, orthocontours would be a great tool to use for that. We use them again to model migration pathways, and they are lines that follow maximum gradient. So let's go ahead and make some orthocontours. To make orthocontours, we're going to go to Display, Grid, and Orthocontours. We'll go ahead and hit OK to this window, and this brings up another window prompt. It's going to ask us for a grid file, which we are going to base our orthocontour pics on. And you can see here, there's a Create button next to Seed Point Culture File. This file holds our orthocontour pics. We'll go ahead and hit Create here, and we'll go and overwrite this, which I prepared just to blank it out. And you can see here, just underneath that, there's a Create New Seed Point Group button. And what this is a kind of a sub file that resides within your culture file. And this holds your also holds your pics. We'll go ahead and hit here, hit OK. And now that we've made those two files, we are ready to start making orthocontours. Before we jump into that, you'll notice we have several options here we can change. We can also change the color, the line style. We can control whether or not you want your orthocontours to continue through faults. But for now, I'm going to leave all the settings as they are. I'm going to check this box here that says Open in Edit Mode. So we'll check that here, and we'll hit OK. This brings up my Seed Point Editor window. It's this tiny little window. Sometimes it gets hidden easily, so you have to watch out for that. If we go ahead and hit this little green plus icon here, it says Add Orthocontour Seed Point Mode. We'll go ahead and check that. And you can see my cursor has changed from a white arrow to a plus sign. That means we're ready to start making orthocontours. So I'm just going to surround our structural high here just by left clicking. And you can see right here, my orthocontours are suggesting the fluid patterns that might be surrounding my structural high. Okay, you can go around here too in the structural high. When you're finished, right click and go over here to hit Save. Make sure all of our settings are correct. That's our correct file. That's our correct Seed Point Culture file. And we'll go ahead and hit OK. And before we close this webinar out, I want to show you what these marks might look like in 3D Viewer. Let me get that out for you. You can see here that these markings are a great tool to highlight structural changes, especially when working in unison with our 3D display. You see right here, they really accentuate the rates at which our structure is changing. They're a great visual tool. Anyway. And that'll conclude our webinar for this evening. I'd like to thank everyone for joining. If you have any questions, you can email us at support@petrosys.com.au, or you can also type them in this chat log right here. Let me go ahead and get that open. I will be here for another 2-3 minutes if anyone has any questions.